Right, good afternoon, grade 11s. Welcome back to a brand new section in Information Technology, grade 11. My name is Mr. Freeman, and as I just said, we finally reached the end of another big section, big topic in your grade 11 curriculum, which is reading from text files and writing to them, and we incorporated all of that with arrays that you've learned in the previous section. And we finally did some reporting. So there's a bit of practicing for you to do on that section. Please don't just move on to the next one. Use the DBE textbooks and use those vast number of activities that they've got available. Also, there must be plenty of places where you can find some past papers. I can also dig around and see if you can't give that as a bit of an assignment to do while we carry on with the new work. So, right, today's topic, brand new section, as I said, is an introduction to user-defined methods. So we're going to firstly explore what they are, and maybe if there's time, dabble a bit in a sort of an introduction into Delphi with procedures. Okay, let's begin. So what do I want to reach today? Well, I want to define and describe user-defined methods on a basic overview. Exactly what is it? I want us to then differentiate between a function and a procedure, because in effect, these methods are always either a function or a procedure, and we just got to understand the difference again. You've learned about that before from me and surely before that, but we're just going to explore that again. And then we're going to give the structure of a simple procedure. How do we declare it? How do we define it? Where do we do it in the program? And how does it fit in? And as I said, then we're going to use a simple procedure to solve a simple problem in Delphi. Okay, so firstly, you've got to define and describe user-defined methods. So a method is a subprogram, or what they call a subroutine. What is that? So it's just a small piece of code written somewhere that performs a specific task. Examples that you would have known or would know at this point would be the built-in ones, so the string and the mathematical methods and so on that you have learned about in previous chapters. And we're looking at a few examples there, like random, copy, and ink. So those are all built-in methods. So random produces a random number. So I would imagine that's probably going to be a function because it returns a random number between 0 and 1. And those are built in, as well as the copy that you've known and the ink or increment. So those are all little methods built in, little subroutines that whenever we need them, we just call them from wherever we are, and it's done. So as I said, they're built in, they're predefined, and they were written by the guys who develop and keep on developing Delphi. Now, what we're going to be doing is we're going to expand to that, and we're going to create user-defined methods. They are written by you, the user, to perform a specific task. Well, what task? Well, it's going to be a task that's not usually used by many programmers around the world, because if it was, then it would have been built in. It would have been part of Delphi. But what you will find as you go on in programming is sometimes you need a little subroutine for yourself, for your program, that you may want to use over and over again in your program, or even in other programs. So you would keep it somewhere and you can just reuse that. So just like in built-in methods, user-defined methods can be defined and used anywhere in a program, or even from one program into another program. So I think I touched on that, but why are methods useful? Okay, so I've just done a bit of research here, and I could find 5 reasons quickly. So firstly, it's more readable. Okay, so by calling methods, you can use a single line of code to complete a task that you would normally take multiple lines to do it without this method. So in other words, if I didn't use a method, now I needed to sort something, now I would have to add a whole bunch of lines there. And yeah, you could probably have comments and so on. but it will be a lot more readable if you could just call some sort of sorting method. So now I know you're sorting this array, so you call sort array as a parameter, and it's very easy to follow. It's simple, and you've done it before, so there won't be any errors in there. Secondly, it's modular. Now, what do we understand under modular? Well, if you think back in grade 10 theory, think about the modular design of a motherboard. So a motherboard is not just one thing that you buy. It's the board, but then it's got some expansion slots and sockets so that you can mix and match and add different levels of RAM. More RAM, you can add different things in your expansion slot, so you can basically customize a motherboard for yourself. Which is great because it helps with updates, it helps if something is broken, or if you just wanted to upgrade something. So similar to that, modular in programming is a program is then broken into simpler little subtasks, okay? Just like a piece of RAM or a CPU or so on. So you just have simple subtasks or subroutines ready for you to use wherever you want. And these subtasks are kept as separate little modules. This enhances the accuracy of the program. Why? Because you've already developed it. You've already made sure that it is accurate and works. Now you're just reusing it again. So you're not going to be worried about whether it is going to work, whether you're going to get some runtime error or logical error or so on. You know it already works, so it enhances the accuracy, as well as the clarity of the program. What I probably didn't mention here, but I'm thinking about this right now, it's also going to save you time. You don't have to keep on coding all those lines over and over again. Yes, I suppose you can copy and paste, but you know it still does. It makes it still look messy. And then the third point over here, which is sort of a continuation of what I just said, it is less repetitive. So you can shorten the code. You're not copying and pasting. So it's shortened code. That is, if a method is called several times, it saves repetition of the same code. And in our example today, we're going to actually do that, where we call the same method more than once. Okay, so it's easier to debug. So if you've got some logical error in your code, logical, in other words, it runs, it doesn't break, but then the result that you're seeing is not what you expected. So it's easier to debug because there's not a lot of code in there. You can step through your statements a lot quicker and a lot easier with more clarity. And then it's easier to update. So if you needed to change your little subroutine or method for whatever reason, you simply just go and change it in its code, in its section once. And then every single place where you've called it, you would have your changes resulting in there. So you don't have to go and see, where did I place this piece of code 10 times? Now I've got to go change every single occurrence. Over here, we can just update it once in our method. So I've taken this little screenshot from the grade 11 practical book on page 130. And it's a nice little table here that shows us the difference between the two main types of methods. One is a function and the other one's a procedure. Now, you've seen this before, but let's go through it again. So a function is a call to a function is always within another statement. Now we've spoken about this. So where's my function over here? My function is the string to int function. What does it do? Well, you know, it takes a piece of string, a piece of text, and it converts it into an int. But then you want to do something with that conversion that you've returned. That's why it's part of another statement. I want to do something with this that I've returned. And what am I doing in this example? I'm storing it in an integer variable inum. So it's never on its own. It's always as part of a statement, either inside another function or procedure, or like this on the right-hand side of my becomes operator. Here's another example. So there's the square function, so that returns the square of a specific value. As I said, return. So it would, if it was 5, what will be returned now is the answer 25, and that I'm going to store in this variable over here, again, part of the statement. Whereas a procedure call is a standalone statement, never part of another statement. It's always on its own. Yes, you can have a function embedded as a parameter of a procedure, but in effect, the procedure is always on its own. And here's a good example, memDisplay.clear. So clear is the procedure, and it is from the memDisplay or the memo class. So that was defined, clear was defined in the memo class, and you can use it on any memo. And what it basically does is, as you all know, it clears the memo. The same here, set focus. Set focus is another procedure that was defined by the guys who write at Delphi in the edit class. So you can add the set focus on any edit, and set focus would obviously be repeated in many of these components classes that you find if you design a form. Okay, so there's the difference. So that's the first difference. Procedure, standalone statement, function, part of a statement. Then a function always returns a single value, always one value, never multiple values. That will be too confusing. So at the end, my function does a job, whatever that job may be that it was designed for, but in the end, it returns something. So let's look at this random over here. Random is going to return a random value for me. So in its place, imagine after random is executed and I get an answer of 0.567. That 0.567 is replaces whatever random was, and now I can do what with it? I'm storing it in a variable. So it returns a single value. And that is obviously because of a function, why I always call it from another statement. It returns a value. So a procedure, just like a function, does some work, but it never returns anything. It never returns a value ever. And that is why it is a statement on its own. So here's an example, show message. Delphi is fun. It's just going to display a little message window with this text over there. It doesn't return something. It doesn't return true or false or a word or anything. It just does a simple job. So I would always like to think of a function as a procedure with a benefit. It's a procedure that also returns a value. Okay, so the last bit over here at the bottom, a function starts with a keyword function. Those are just little obvious things that we would get to when I show you how to declare a function or a procedure. So when we declare a function, we say function and then the name of the function. When we declare a procedure, goodness me, they decided let's use the word procedure and then the name of the procedure. Because, lastly, a function returns something, you have to assign it a data type. You got to say, okay, this function is going to return something, but it's going to return a string or an int or an array or an object. Objects you'll learn about next year, or maybe at the end of this year, probably next year with all the stuff that's going on. It could be any type. It could even be a component. You can make a function that returns a radio button, for example. A function can return a text file. Anything that you can think of, a function will return. But for our curriculum, it will usually be a simple int, a real, a boolean, or a string. And obviously, because a procedure does not return anything, it is never assigned a data type because it doesn't return anything. Okay, so hopefully you understand this. You can always go back to page 130 if you forget any of this. Okay, so we got our methods. Methods are either functions or procedures, but then there are subtypes within that. So it gets a little bit more involved, and we're going to start today with our first type. But let's just give an overview of what they are. So the first one, the first subtype, is a procedure without parameters. Okay, so I'm calling this procedure, but this procedure can do its job on its own. It doesn't need any additional information in order for it to do its job. Think if you can think of an example that is already built into Delphi that does exactly that. And then the second one is a procedure with parameters. So this type of procedure wants to do its job, but it doesn't have all the information for it to do its job. So for that, you're required to give him that information. And the only way you can give a procedure the additional information is through a parameter, unless it's globally defined variables that it can pick up from. But that's still a procedure with the required information because it can find it somewhere in the program. This is if I want to pass something that is a value, some information that the procedure can't find anywhere else. So you've got to give it to him. Think of an example for that. And then thirdly is functions without parameters. So yeah, it's like a procedure, but it's going to return an answer, but an answer where it doesn't require any additional information. It can do everything on its own. And fourth, last one, I hope you can guess it. That is a function with parameters. Again, it needs additional information from you in order to do its task. And then right at the end, it returns one specific value of one specific type. Okay, any ideas what built-in functions you can think of as an example over here? Well, let's look at some of them. So the first one, without parameters, there are many, but this is one example. So I've got a rich edit, and I can apply dot clear. So this procedure over here is defined in my rich edit class, and its job, when called from a specific rich edit, goes and clears all the lines of text in it so that it has no text left over. Okay, so that's the first example. Now, what about a procedure with parameters? Well, the one that I thought of is the reset procedure, the one we've just done up until yesterday, I guess. So the reset procedure, that is the one that allows us to open a file. Now, the reset procedure would love to open a file, but you need to tell him which file needs to open. Okay? Because you may have multiple files in there. It wouldn't know which file to open unless you tell it which file to open. And again, we tell it by sending a parameter of the name of the file that we want to open. So in my brackets, I send my additional information. Now, in this case, reset only needs one piece of information. The delete function, the delete procedure requires 3 pieces of information. Where do I want to delete from where, and how many characters? So you know what that structure is. It's the 3 parameters, and each one following the other one split by a comma. And you know by now that the order is very important, because Delphi can't just guess the order. You've got to specify the correct order. Okay, and then functions without parameters. Here's an example. So the function date returns the current date. And because it's a function, it's never called on its own. It's always part of another statement. That's why I'm just created this current date variable that stores date. So the type over here would be of date time type. And as you can see, there's no parameters. It just returns, it can do its job. It basically goes to the system and checks what is the current exact date today, and returns that. And then lastly, well, here's a function with a parameter. So the file exists function, it wants to, what is its job? It needs to check if a file exists. But again, like with reset, you need to tell it which file, and we do that with a parameter over there. And again, this is part of a bigger statement. And in this example, it's inside an if statement. Okay, so we're going to look at the first type today, which is procedures without parameters, and then we'll move forward with the next types in the following lessons. So firstly, we've got to tackle here is to declare, how to declare, and how to define a procedure with no parameters. So there are two steps here. The first thing that we have to do is we've got to declare it. We've got to say this thing is somewhere, this thing exists, and we've got to declare it somewhere. And in the second part, defining a procedure, that is the meat of it. In other words, the task, those lines of code, that's the subroutine, is going to go into its body, and that's got to be placed somewhere. So a procedure is declared as a method of the form. Now we are mostly using forms still in grade 11. That's why I placed that there. So a procedure is declared as a method of the form as follows. So simply you go to the private section. Now you must have seen the private and the public section. And typically in grade 11, we would enter our procedures or declare our procedures in the private section. What's the difference? Well, that's just the scope of what you are allowing your procedure to live in. In other words, if I put it in private, it means any piece of section of code inside this form will be able to access this procedure. That's private because it's only inside the form, inside the unit. If I place my procedure in public, it will work exactly the same way, but that procedure will not only just be allowed from inside the form, it will be allowed to be used from outside the form. Now, you haven't done this part of programming yet. We will get to that in a later stage, but later on, you will start using one form to access methods from a different form. And if that is the functionality of that method, then you would need to place it in private. In public. But we're going to just be using one form, so we're going to be placing it in private. And after my declaration, the procedure is then defined in the body of the program as follows. So what I mean the body is wherever all those buttons and events are that you've done up till now. So you would have double-clicked on a button and create an event. Now that event is actually a procedure in its own right. And in your procedure would, or at least the definition of that procedure would be sitting somewhere between those, never inside an existing procedure. You wouldn't define one procedure inside the definition of another procedure. It will always be separate, like our little button events that are separate but underneath each other. You don't have to put it at the end or in the middle or in the beginning. You can put it anywhere you want. And the basic syntax for that, if I want to define it, is you call procedure. Maybe I should go back to private here where I declare it. So you call procedure, and you call whatever the name is that you want to give this procedure, followed by a semicolon. In my definition, where I'm going to have my code, a little bit further down in my implementation of my class, I call procedure, but then my class name, the name of the class, not the unit, the name that you gave the form, dot name of procedure. So there's a slight difference. You add this part, the name of the form, dot the name of procedure. Then optionally you can declare some variables, and then you start again, and then over here is the body of the procedure. In other words, the actual task that it needs to fulfill. That's what you place in here. So now we're going to actually look at an example on page 132 of the grade 11 practical textbook, just to show you what we can do in Delphi. So I'm going to have this open over here. This is example 6.2. It's based on the 3numbers_p project that you can get from that downloads folder that I've given you from, I think it's chapter 6, yes. So we're going to carry on with that. And I've also got open my Delphi program over here. So it basically has edits, number 1, 2, and 3, a little button, and this is a rich edit called results. So now we're going to be doing some stuff with these numbers when I hit on the determine button. So what they already have in here, they got 3 procedures. A procedure called sum of numbers that determines and display the sum of the 3 numbers in my edits. And then there's going to be a procedure called highest that determines and displays the highest of the 3 numbers. Okay. And then there's going to be a procedure called line that does 2 things. It's firstly going to display something stored in a string, and then it's going to follow up with the next line with a bunch of equal signs in the next line, and so on. And that string that I'll be displaying from line would be whatever the answer was that these procedures have produced. Because remember, procedure can't return a string, but it can change an existing variable, and that's what I'll be displaying each time I call line. Okay, so let's look at the code quickly. So we start off with my private declaration. Maybe I must just show you here. My class name of type tform is called tform3numbers. Okay, so that's the class name. Then there's the one procedure that was added in there when we double clicked on that button the first time. And here's my declarations of my procedure. So as we said, we start off in our private section as procedure, and then the name of the procedure that we want to give it. So there's sum of numbers, there's highest, and there's lines. Okay, so let's look at the determine click section over here. So this is my procedure for my button. And as I said previously, here's my definitions of each of my procedures that we've defined as users. If I want to see what's going on in highest, I can simply hold down control and hover over highest. So if you hold down control, there's a bit of a hyperlink that appears. And if I click on highest, it takes me straight to the body or definition of this procedure. And yes, there's another reason why you want to do that, because it's easy for navigation. You don't have to go and scroll through your code until you get to that piece that's going to determine the highest value of 3 numbers. And so on. So there's my determine click. So the first thing it does is it takes from each edit, converts each value into ints and store them in inum1, inum2, inum3. Where were they declared? Well, not there. Okay, they were declared globally over here. I wonder why. Usually, if I declare it globally, it means I want it to be accessed from multiple events or procedures or functions. And this is exactly what I'm going to do, because the button over here provides values to inum2 and 3, but my procedures would do some work using those things. And they need to be able to access it, and that's why it's globally defined over here. And then lastly, I've got my sDisplay of type string. So whatever my procedures are going to be doing, it's going to change the value of display. So let's carry on over here. So that was the first thing that this button does. Then for some reason, it calls my procedure sum of numbers, and that's how you call that procedure. You simply type the name of that procedure as it was declared at the top, specifically for procedures that are defined inside our form, which is what we are doing in grade 11. So we simply just call the name of my declaration, and then it's going to jump to sum of numbers, okay, and then execute sum of numbers first, one line at a time, and it's going to do its task. Then it's going to go at the end of sum of numbers, it's going to jump back to here in my button and go to the next line. Now it's going to execute line, so now it needs to jump to line again, which is there, execute its lines of code, apologies, and when it's done, it jumps back to line. And then it goes to the next statement and executes the next procedure, which is over there. And that procedure gets executed one line at a time. It does its work. I reach the end of it, and now I go back to wherever it was called from. And then finally, I call line again, which means I go back to line's body, execute its stuff, and go back here to the end. And finally, I finish my buttons procedure, and I go back to the form, and the form waits for the next piece of input. So up until now, you've been used to doing linear programming. So you would have a button or multiple buttons, and each button each line of code in your button would be executed from the top all the way to the bottom. But now with methods and functions that we're going to define ourselves, you would find that the code jumps from one place to the other depending on which procedure or function I'm calling. So that is something that you need to also understand here. Now at this point, I want to say some of you may have already wondered, what is the point? I could do this in one button without functions and procedures, and it'll be a lot easier for me. I don't have to jump around through classes. What is the point? Why are we doing this? Well, please understand that these things that I'm trying to teach you are taken in little baby steps. So step number one, I'm going to show you a basic idea of procedures. So don't think about why I'm doing it. Just think about that I am trying to prove a point here. I'm trying to show you how functions and procedures work. So just try and focus on that. Okay, so let's run this program. So the first thing I'm going to do is enter some values. Okay, and it's now going to determine my answer. So the first thing it did, if I can just move this to the side, it fetched my numbers, populated them into my variables. Then it called sum of numbers. Now, sum of numbers, what does that do? Sum of numbers literally takes and gets the sum of the three numbers and stores it in here. And then I make my display string sum of, or sum colon, and there's my answer. And that's where sum 7 comes from. Well, not exactly, because that's still a string. It's only after I execute my next procedure line where I actually go and say, okay, take what is in display and display it into my rich edit, followed by one line. Okay, so that is actually where I place it in my rich edit. This stage was just a string. And then, well, we can't really see this. Let's just scroll down. Next thing that happens is it executes highest, and highest just simply goes and says, does a bit of a comparison. Now, this is a bit of a, it doesn't use arrays. So this is like it's almost like a grade 10 little algorithm, finding the highest value of three numbers. So it says, okay, take two numbers, determine if the one's bigger than the other one. And if the first one is also bigger than the third one, then we know num1 is the biggest. Else, okay, so that's not the case. We're going to check, okay, well, if num2 is greater than 3, then we know num2 was the biggest, because we know now if it goes into the else, it wasn't that as well as that. So we know num1 is not the biggest. Now we just check, okay, well, if num2 is greater than 3, then we know num2 is the biggest, else num3 is the highest. And then again, the last thing we do is we simply say, okay, well, display is now overwritten with this value, which is highest number, and which one is the highest number. And then lastly, from my button, I call lines again. Now it displays that string followed by that same line between them. So again, here's an example of repetition using the same procedure multiple times. Okay, so if I go to my determine click and I place a little stop on there and I run it again, and I place 1, 2, and was it 4? I think it was. And now if I did, oh, wow, why can't I want to run with debugging and it didn't do that. Okay, doesn't matter. You understand the idea that the code jumps from the one procedure to the other. So let's put this in practice now. Okay, so I want to now expand this. I want to expand this project, and we want to now quickly, before the time runs out, add a procedure of our own, and we're going to just call it smallest. Now it's going to determine, instead of the biggest, it's going to determine the smallest of the 3 members and store the answer in S line, so that what from the button we can call that procedure line again, which is then going to display my answer followed by that little line behind it. Okay, so let's see if we can do that. So we go all the way to the top. So somewhere here, I'm going to, well, let's put it over there. It doesn't really matter. So I'm going to call it procedure. So it's procedure. Okay, and smallest, and my semicolon. Now, yes, you can. Now, the next step is to somewhere in your code, and guys, please help your teachers, and wherever you do it, put it in a chronological order. It just makes our life a little bit easier marking your exams, and it will keep us from making some mistakes, causing you to lose some marks, but it doesn't really matter. Now we have to go and define this procedure somewhere. Now, you've got one of 2 options. You're either going to go and type procedure, the name of the class, followed by whatever we called this procedure over here, or we can use a little shortcut. So whenever you define a new functional procedure over here, we can call the shortcut Control-Shift-C. The moment you do that, Control-Shift-C, it looks at my definition, tries and finds any of the procedures that you've declared over here that doesn't have an implementation or a definition yet, and it creates it for you. Look at what it just done. Just place that in for us. So please, it saves a lot of time. Do that, and you'll know that you won't make a mistake. Delphi does this for you. So that makes it a lot easier. And what are we going to do? Well, we're going to do exactly the opposite of what was done in highest. So I'm going to cheat a bit here, and I'm going to copy this and place it in there. Okay, did I make any mistakes? No, it doesn't look like it. And I guess what I'm going to be doing is I small and replace I large with I small. And actually, to make it the opposite, we're simply just going to change our little operators, those logical operators. So from a greater than to a smaller than, to a smaller than, and to a smaller than. That, in theory, should solve our little problem. Okay, let's see if that, well, will it work if I call it now? Think about it. Let's see if it works. It seems to be working. Let's carry on. So I'm going to use that same, well, let's make that one 2 and this one 1, so you don't think I'm cheating. And now I'm going to call it again. So let's see if I've got the smallest one. No, I don't. Why not? Why is it not there? Well, the reason is because I didn't call it from my button. I need to now call this procedure so that it works from my button as well. So let's carry on doing that. So I think I called it smallest. Yes, there we go. My auto invoke works there. So smallest followed by line again. Now I can run it. And I have a 2, a 1, and a 4, and I'm expecting the 1 to be returned. Let's see. Okie dokes, that's me copying, pasting, not changing the value from highest to smallest, but I think you understand the idea over here. The answer was correct. My output was incorrect, but the answer at least gives me the one that is the smallest. So before I change this, all I needed to do was the smallest number becomes that. But I'm sure you agree, I don't have to run it now, it will work. Right, so that is that. That's your first taste of implementing your own procedure. Yes, no parameters. It didn't need any additional information. It could find all its information from the variables as they were declared globally. It didn't need anything else. So we've defined these user methods. We've differentiated between a function and a procedure. Hopefully by now you definitely know the difference. We've looked at the structure of a procedure, and we've gone and we've implemented our first procedure in Delphi. Now, tomorrow, we're going to look at procedures with parameters. Now, that's a little bit more involved, so because I'll have to show you exactly where in my procedure definition, and hopefully you can think about that and guess where it's going to be so that you're ready for tomorrow. Where am I going to define my parameter or parameters that would be needed by my procedure? And then we're going to look at different types of parameters. You know, you get different types. There's formal and actual, and I'll discuss and show you the differences between them. You probably won't worry about this in practical, but in your theory exam, you need to know the difference between the two. Then we're going to discuss method signatures, what they are, and how these method signatures allow us to implement method overloading. And that is when I have two examples of the same procedure. So please, guys, this is just a taste of it. Tomorrow we're going to delve a little bit deeper. And I hope to see you all there. So if there aren't any questions from anybody at this stage, then we will call it quits for today. Have a